Good day everyone, this is Mr. Fugay here, and this video we're going to be looking specifically at this problem number 10 and going into an in-depth analysis of the different tasks that it's having us do. So this is certainly at the top of the food chain when it comes to the difficulty level and the amount of application that we have to use with the first derivative test and increasing decreasing intervals. So let's go ahead and get into it. So we start right away with a function f. And it is a twice differentiable function defined on the interval between negative 2.1 and 2.1, with f of 1 being equal to negative 2. So that we only know one value of the original function, okay? However, the graph of f prime, on the other hand, is shown, and it says above, but it's actually here to the right. The graph of f prime crosses the x-axis at negative 2 and positive 2. So they've just wanted to officially declare that, even though we can kind of see that. It has a horizontal tangent line here at negative 1. And it looks like it's also going through the point 1, comma 3, which is going to be important. Keep in mind that this is the graph of f prime. Finally, there's another piece of information here. It says let g now be a function defined by g of x equals e raised to the f of x. So g is completely separate, even though f of x is involved in it. So we have all that information. We're going to come back and reference all of that stuff throughout these next 4 parts. So the first part says write the equation for the tangent line to the graph of g at x equals 1. So as a reminder here for part A, that we need to figure out a point on g, and we need to find the slope on g at that point. Well, the point that g is, well, x equals 1, so it's going to be, we need to find what g of 1 is actually going to equal, because that's going to give me the y value. Well, g of 1 is going to be equal to, according to the definition, e raised to the f of 1, which is going to be e, and then f of 1 is actually given up there in the blue highlighter. So that's going to be e to the negative second, which means that my point, my official point here will be 1, comma, and then e to the negative second is 1 over e squared. So there's my point. To find my slope, we're going to need to find the derivative of g. So we're going to find g prime of x, which that is going to be equal to e to the f of x, e to the something, times the derivative of that exponent. So in this case, f prime of x. We are going to need to reference this derivative a few times throughout the next parts, so just keep that in mind here. Since we're trying to find the equation of the tangent line at x equals 1, we're going to evaluate the slope at 1. So it's going to be g prime of 1 is equal to e raised to the f of 1 times f prime of 1. Well, when we're doing this here, we're going to get e. Now, f of 1, we've got to go back and remember that that was given to us there in blue highlighter, is equal to negative 2. F prime of 1 is actually given right here. So this is the x value, this is the f prime value. So that means that the slope here, f prime of 1, is going to be equal to 3. Therefore, my slope is going to be 3 over e squared. So we now have our slope here, we have our point, and so all we have to do is write the equation in point-slope form. So that's going to look like this. And that's part A. And there's our answer for part A. Okay. Moving to part B, it's asking us to find the average rate of change of g prime. Whenever you see average rate of change, I want you to remember immediately average rate of change is the slope of the secant line, aka the slope formula, meaning like the original slope formula you learned back in Algebra 1, y2 minus y1 over x2 minus x1. And we're finding that average rate of change of the graph g prime. So that's going to be the y values of the y values of g prime, or the output values of g prime, is what we're using to find the average rate of. And then the last thing it tells us is it gives us that interval. So the formula that we're going to set up for this is we're going to evaluate g prime at 2. We're going to subtract what g prime of negative 2 is, and we're going to write that over 2 minus negative 2, which is the same thing as 2 plus 2. Now, what we need to go do right now is evaluate what g prime of 2 and g prime of negative 2 are. And in order to do that, I'm going to go over here to the right. Remember that we know the derivative from part A is e to the f of x times f prime of x. So we are going to evaluate now g of 2 and g prime of negative 2. So when we do that, this becomes e to the f of 2 times f prime of 2. This is going to be e to the f of negative 2 times f prime of negative 2. So what do we get for this? Well, e to the f of 2, we don't actually know anything about f of 2. The only value from the original function that I know was f of 1. So that's sort of a problem, except for the fact, so let's just write that in for now, e raised to the f of 2. We don't know what that is yet. However, f prime of 2, we do know. Remember, this is the graph of f prime. F of 2 is equal to 0. F prime of 2 is equal to 0. So because of that, the answer I get is 0. And likewise, down here, we're going to get e raised to the f of negative 2. F prime of negative 2 is also going to be 0. So that's going to be another 0. So we get 0 for both of these. And when I insert that back in, that's just obviously going to give us 0 over 0 divided by 4. Let's just say 0 minus 0. My apologies. And so our answer here is going to be 0. Okay, so we're moving to part C now. So in the interval, the open interval from negative 2.1 to positive 2.1, we want to find all values at which of x, which g has a local minimum. So when you see the word local minimum, what I want you to remind yourself is that we are looking for when does g prime change from a negative value to a positive value. And so to do that, we're going to do a sign chart. But before we can find a sign chart, we need to identify any critical numbers of g. So by definition, that means we're going to take the derivative of g, which again, we found back in part A. It's e to the f of x times f prime of x. We need to evaluate when the derivative is equal to 0 and when the derivative is undefined. We're going to look at when the derivative is equal to 0 first. And in fact, we don't need to find when the derivative is undefined because if you go back to the beginning, they said f was a twice differentiable function. So we don't need to look at any of that. So we're going to set this equal to 0, which means we're going to set each of these factors equal to 0. So when I do that, we're going to set that equal to 0 and that equal to 0. Well, e to the f of x equals 0, the question is, what exponent would allow e to equal 0? And the answer to that is none. And quick side note, if you don't know why that is, there are 3 scenarios I want you to consider right now, okay? E to anything positive, so e to the first, e to the second, e to the third, is going to give you a positive answer. E to the negative, so when you think about this now, e to the negative 5 is actually 1 over e to the 5th. So that actually is going to be a positive answer. It's a small positive answer. It's a fractional answer, but it's a positive answer. And lastly, e to the 0 is 1, which also is a positive answer. So that means that e to the something can never equal 0. Therefore, for this first one, there's going to be no solution to this. However, f prime, we need to look at when it equal to 0. We're going to go back to this graph. When does f prime equal 0? Well, we found those 2 spots here and here already. So it's going to be 2 values. It's going to be x equals 2 and x equals negative 2. So now let's create our sign chart. All right, so we have negative 2, we have 2. And again, we're only looking at the open interval from negative 2.1 to 2.1, as they stated in the original premise of the problem. So we need to pick a value in each of these 3 regions. So we have our yellow region, this green region here, and this blue region here. And so take a moment if you want to pause this right now to do those different tests, and then I'll have it back here on the screen here for you in just a moment. Okay, welcome back. So let's look in, we'll start with the easiest one. We'll start in the middle region, actually, in the green region here. So I tested x equals 0. So when I plugged this in, I got e to the f of 0 times f prime of 0. As we mentioned, e to the anything is always a positive answer, so we're set. F prime of 0 is actually going to be a positive answer. And again, if you look at the graph here, we don't know what it is, but we know that it's going to be above the x-axis here. So that's the reasoning why that is also positive. Therefore, our first region is going to be positive. Let's go to the yellow region on the left. So again, we had to pick a number between negative 2 and negative 2.1 on that interval. So we're going to say negative 2.09. And when I do that, e to the anything again is positive. So we've got that covered. F prime of negative 2.09. So that's just to the left of negative 2. So that's over here. So that is going to be below the x-axis. So that is a negative value. Therefore, my second region is negative. And the same argument can be said on the region on the right here. Again, e to the anything is positive. f prime of 2.09 is just to the right of 2. It's going to be a negative value, so that's going to also give me negative. Since they've been asking here about a relative minimum, we're going to go from decreasing to increasing, increasing to decreasing. Therefore, our relative minimum is occurring at negative 2. Here is my explanation and also rationale for that final answer. Final part is going to be part D, all right? We have our second derivative given, and what they simply want us to do here, and I say simple kind of almost ironically, is they just want us to say if g double prime of negative 1 is positive, negative, or 0. That's it. That's all they want. Not that hard, right? Except look at the function you're dealing with. Lots of stuff going on here. So let's go ahead and let's plug in that negative 1 into all of the pieces, and then we're going to walk through each of the individual slices of this to figure out what it's actually doing. All right. So let's start with this first part here in yellow. We've said this already numerous times in this question. E to the anything is going to be a positive answer. So I don't think I need to explain any more about that using the same logic that I showed earlier in the video. Let's move to the second section. This second term right here, okay? When we look at this second term, is going to end up being positive. And the reason why, we're going to look back up at the function here. At negative 1, the value of f prime is going to be above the x-axis. So because it's above the x-axis, it's going to be a positive value. And then, of course, it doesn't even actually matter because when you were going to square it anyways, it was still going to make it positive regardless. So, but I still wanted to show you up in the graph just in case, okay? And then our final term here, which I'm going to highlight here in purple, f double prime of negative 1 is the slope of f prime. So I'm going to write that down. That is the slope of f prime. So we have to look at what the slope of the curve is when we scroll up here. And the slope of f prime at negative 1 was actually explicitly given to us. It was right here. It is a horizontal tangent line, which means that this is going to be equal to 0. So it's going to be equal to 0 here. And so when you take a positive number and you multiply it over the quantity positive plus 0, this is going to give you a positive answer regardless here. So therefore, g double prime of negative 1, and it asks us to justify, is positive. And what I would declare as the reasoning why here is to just explain that the e term is positive, the f double prime squared term is positive, so there are no negative values in here, and there's also no factors that are 0. That's important, all right? There is a 0 in there, but it's not a factor. That's the reasoning why g double prime of negative 1 is positive. So again, this was probably the hardest question of the entire practice set here. Lots of in-depth stuff, but it's all in the hopes of hopefully helping you be a little more comfortable working with the first derivative. Thank you for watching.